With me here in the studio this morning from Roskill, joined by Jessica Roberts and Adam Coggins. Good morning, good to see you both.
Good morning.
Morning, Andrew.
Adam, we're talking titanium. Tell me a little bit more about it and what it's used for.
Okay, so titanium is a light metal. It has various useful properties, one of which is its corrosion resistance. This stems from the fact that it readily forms a thin oxide layer on contact with air, and this acts as kind of a barrier protecting the metal underneath. This makes it really useful in kind of harsh environments where other metals might undergo rusting or corrosion. Another property that's really key is that it's a relatively low density metal and it exhibits excellent strength to weight characteristics, particularly when it's alloyed with other metals. So as an example, the most commonly used titanium alloy, which is an alloy containing 6% aluminium, 4% vanadium, this has a comparable strength to many steels, but it's around 40% lighter. In addition to this, titanium exhibits some heat resistance properties, so it will generally retain its properties up to around 400 or 500 degrees.
So what's the supply chain looking like, Jessica?
So titanium metal, I suppose you could call it the much smaller cousin of the titanium pigment sector, which your viewers may be more familiar with. And titanium metal, got to be honest, it's not the most easiest thing to produce. So there are relatively few countries worldwide that have the production technology that can make the first product in the supply chain. So first of all, you start off with titanium sponge. The main countries that are making that, you're really looking at Japan, so that's Osaka, Toho Titanium. And then you've got Russia, that's the big producer there, is VSMPO of Visma. Then you've got the Kazakhs, and then there's a pretty good production base in the USA as well. And then in China, there is quite a substantial sponge production base, but a lot of that output is really industrial grade quality, and a very small proportion of that is suitable for the higher grade markets like aerospace. And then the next step in the supply chain, you've got the melters. So these guys are taking the sponge and they're melting it together with various alloying agents and scrap, and they're making titanium ingot. Titanium ingot, I'd say that production is a little bit more widespread, but still pretty focused. So USA, Japan, Russia, they're really the main producers. And there's also important melting capacity in the UK and also in France as well. And then if you look at the next stage of the supply chain, say you've got the titanium mill product producers, and these are the guys that are taking the ingot and they're fabricating it and they're making it into the sort of all wonderful different shapes that titanium can be used in. So on the flat product side, you've got plate and sheet, and they're going to be used in making things like containment vessels for the chemical industry. And then long products such as tube that might also be used in chemical sector, nuclear sector, and so on.
Well, just picking up on a point which you said a moment ago, aerospace. Adam, what give us a bit more detail. What are some of the main markets for titanium?
Yes, so aerospace is a big one. It makes up a large portion of the demand for titanium, along with the industrial sector. And both of these markets use titanium for the properties that I mentioned earlier. So in the industrial sector, it tends to be the corrosion resistance, which is important. And a lot of the demand comes from the chemical sector, as Jess mentioned, particularly the chlorine industry, but also in power generation, nuclear power stations, coal-fired power stations, that sort of thing. In terms of aerospace, titanium is used widely in aircraft engines and in the airframes. Here it's the strength to weight ratio, which is really important, but also other properties such as the compatibility of titanium with carbon fiber reinforced polymer, for example. So you can use titanium alongside composites and it won't undergo electrochemical corrosion, which is a problem for other metals. And essentially, this means that if you have an increased use of composites in commercial airframes, it tends to drive titanium demand as well. So that's one of the key drivers for titanium use. Another important feature actually of the aerospace industry is that due to the rigid specifications for aerospace components and the amount of machining that is carried out, the volume of titanium that a manufacturer has to procure compared to the amount which ends up in the aircraft, which we call the buy-to-fly ratio, can actually be really high. And this increases the price associated with using titanium. Also means there's a lot of scrap available which can potentially be recycled upstream.
What about automotive?
It is used in automotive. It's more of a niche market. Tends to be used in some more specific applications and in maybe higher end models of car.
Right.
One example that jumps to mind, I believe Tesla has used a titanium plate in the underbody of their car, but it's a potential growth market. But yeah, generally is a smaller use of titanium.
And what about new technologies, Jessica?
Yeah, well, I think just going back to one of the points that Adam made earlier about the buy to fly ratio is really critical at the moment, because titanium is a fantastic metal to use. It's got all these wonderful properties, but it's quite expensive. So for an industrial grade titanium sponge, you're looking at about $8 per kilogram. So obviously, if you can reduce the amount of scrap that's being generated in the sector, then you're really going to reduce costs across an array of different industries. And there have been some really, to be fair, some huge efforts made by the industry to reduce the scrap volumes made. So I know that Boeing has worked particularly hard to make sure that the scrap that's being generated in the manufacture of its components is making its way back into the supply chain. But ultimately, something needs to happen, and I think the most exciting prospect at the moment is additive manufacturing or 3D printing. And that's basically where you're printing the exact shape component that you want to use in your final piece. So you might need to do a little bit of finishing and cleaning afterwards, but it can be quite minimal. Now, there's a lot of work at the moment by industry partners to figure out how exactly titanium can be used and which components and the different technologies for 3D printing. But some of the most promising examples, I'd say, would be Norsk Titanium. So they've partnered with Boeing over the last several years, and Norsk Titanium is now partnered with Boeing. It's qualified for certain components in Boeing aircraft, certain structural components. Other industry leaders, I'd say, in additive manufacturing technology, besides Norsk, I would say would be ATI, GE Additive, and also Arconic. So ATI, Arconic, these are two big names in the traditional titanium supply chain. They're both melters and mill product manufacturers. And I think it says something that they're really going behind additive manufacturing technology as well. So I think things do look very promising for the technology. Of course, with anything that's going into aerospace, it's a very critical application. You've got people's lives at risk, obviously. So it's going to take a while for these components to be qualified and tested and approved by the relevant authorities. But it is starting to happen, and I'd say probably by the end of the next decade or so, we'll start to see additive manufactured components in widespread use in aerospace applications, depending on what they are for exactly. So I think additive manufacturing is very exciting, has the potential to be a huge disruptor to supply chains, and for titanium specifically, it could open up hundreds of different applications that weren't possible before. So it's a pretty bright future.
Exciting indeed. Jessica, Adam, good to see you both. Thanks very much.
Thank you.
Thanks, Andrew.